My name is Richard Ignis, and I'm in the Department of Physics and Astronomy at East Tennessee State University. I want to review algebra, especially as it pertains to applying algebra in the sciences and in astronomy, be able to work out problems and find answers to questions. And here I'm talking about the idea of algebra as nothing to it. What I really mean by that is that algebra is kind of like the art of doing nothing. As far as we're concerned, algebra involves two main rules. The first of these is you can add 0. The second one is you can multiply by 1. Those sound like a pair of very unusual rules for math, but the idea is that algebra pertains to the relationships involving equal signs. And you can manipulate those relationships, but you have to preserve the equal sign. You have to respect the equality. As a result, you're not allowed to really change anything. You're only allowed to rearrange things. You're only allowed to make the relation look different, but it has to retain the same content. Therefore, what you have to do is preserve the equality. And if the equality is being preserved, then algebraic manipulation really means that you're doing nothing, but you're doing nothing in a creative way. I'll give you an example. Consider a room filled with furniture. Here, for example, is a door. And maybe our room has a couch, a table, a bookshelf, and a chair. There's our room. Imagine we move the furniture around. We redraw the same room. There's the door again. Maybe we choose to put the couch over on this side, the chair in the corner with the table next to it, and bring the bookshelf against this wall. Same room, same furniture, 4 items, all the same ones, couch, chair, table, and bookshelf, but everything's in a different position. Well, this is like algebra. The two rooms look different, but they have the same content. And that's what I mean by algebra is the art of doing nothing. So why do we bother? Why do we bother doing algebra at all? Well, in rearranging and doing nothing, we can make things look easier for people. We can make it look easier for humans. Let's just have an example here. Consider the expression 4x plus 1 is equal to 17. It's a typical algebraic relation. We have an unknown x. We have an equal sign, so we have a relationship. And the question is, what is the value of x that makes the whole relationship true? The way we typically go about solving this is we want to isolate the x. First, we get rid of this number 1 that's sitting all by itself. So we subtract 1 from both sides. This gives us 4x is equal to 16. The act of subtracting 1 from both sides basically means we've done nothing. What we did to one side, we did to the other. They are offsetting changes. It's like we're moving the furniture around. Okay, we have an x isolated on one side, but it has a coefficient of 4. This is equal to 16. So now we divide by the 4. We divide both sides by 4. 4 divided by 4 leaves us with an x. 16 divided by 4 leaves us with the 4. So the answer here would appear to be x equals 4. But the reality is that these two statements are one and the same. When we say x equals 4, that's equivalent to saying 4x plus 1 equals 17, because x is the solution to that upper problem. X equals 4 is what it takes to make this true. That's equivalent to this truth. Now, instead of solving for x, since algebra is the art of doing nothing, there's a whole bunch of allowable things that we could do to the expression 4x plus 1 equals 17. We could, for example, add 10. If we add 10 to both sides, 4x plus 11, we just added 10 to the 1. If we add 10 to the other side, we get 27. 4x plus 11 equals 27 is one and the same as 4x plus 1 equals 17. Both of these require that x equals 4 for the relationship to be true. But they look different. It's the same content though. Algebra is the art of doing nothing. It's all about rearrangement to make things look better for people.